All right, so now that we've compared and contrasted the p-value and classical methods to some extent, although that'll be something we continue to do as we move, let's think about how many p's there are floating around here. All right, so we have 4 different p's in this problem alone. So let's list what each one of them was to kind of remind ourselves just a little bit here. We had, I'm going to do each one of them separately. We had p0. P0 was the null hypothesis proportion. Null hypothesis proportion. Assumed to be true, unless we can prove it otherwise. And in our case, it was equal to 0.50. Right? Oops. There you go. Then we had P. Now, what's P? You're thinking, well, I don't remember P in there. I remember p-value. Well, but you had a P as well. Let me go back up here. Look at this. This was your null and alternative hypothesis. See that? So P0 is this number over here, a specific number. P is the population proportion, right? What proportion of people in a jury pool should be African American, okay? So you don't know what that is for sure. You know it should be around 0.5, but P is the population proportion. It's African Americans of African American, I can spell, American percentage on jury pool. But it's really for all, oopsie, it's really for all jury panels. It's not just for this particular one. It's saying, you know, that's what it should be in general. It's a population proportion. So because it's a population, you don't really know what it is. I mean, it varies a little bit, moment to moment, whatever. Okay? So you don't ever get to really know what it is. You know what it should be. You know it should be close to 0.5, and you assume that it is, unless you can prove it otherwise. Okay, then you had p hat. P hat, remember we have a formula for, and I reminded of you in the last video when I did, it's x over n, which in our case was 4 over 80, which was 0. Whoa, my goodness, I did that totally wrong. I typed on the wrong area of my computer board. Right? It's the sample proportion. It's the proportion that were actually in, oopsie, in your sample that were African American. Okay? And then you have the p-value. The p-value is, hold on, p-value is the probability of p hat being where it was or lower. P hat being where it is or lower, right? Because it's a left tail. When it, let me go back. It's this whole area you're finding. This whole thing is a p-value. So there's your test statistic, which comes from your p hat, and then this blue area where you're shading, that's your p-value. It's the probability of getting what you got in your sample by accident, by random fluke, by random chance. Let's put it that way. Okay. And I should say where it is. Where it is for us was 0.5, or excuse me, 0.05. Sorry. Okay. So those are 4 different p-values, and you got to keep them all straight. They mean different things. This is the null hypothesis, what you assume to be true. The county is 50%, so you assume that your proportion is 50%. This is the proportion, the population proportion. Since it's for a population, you don't really get to see it. Not ever. You just know it should be vaguely close to what it was for the census for that county. This is p hat, which you actually had in the physical room. And this is p-value, the probability of you getting what you got in the physical room just by random chance. Since it's so dang low, you know something fishy is up and you rejected the null hypothesis. All right? Okay, so with that, let's stop there, and I'll be back in the next video to talk about what makes a p-value more or less significant.